Why, hello, Algebra 1. Welcome to LFEI3, interpreting rate of change and slope. Slope and rate of change, that's what we're looking at today. Let's go ahead and get right into this thing. Determining rates of change. For a function determined in terms of x and y, the rate of change, probably important because, highlighted and stuff, over a part of the domain of the function. In other words, taking a small bit out of this function, it's the ratio that compares the change in y to the change in x. So the rate of change is the change in y divided by the change in x. We've got this example right here. It says this table below shows the year and the cost of sending 1 ounce letters in cents. So in other words, years after 2000, this would be like 2003, 2004, 6, 8, 13, and how many cents these cost, right? So what we're going to do is find the rate of change between two specific time points. If I go from 2003 to 2004, we go from, remember, so we're going to go the change 37 and 37. Well, there's 0 cents per year change, right? It's like 0 divided by 1. It doesn't change by anything. If I go from 2004 to 2006, right, our change in y would be 39 minus 37 divided by 6 minus 4. In other words, that's 2 divided by 2. On average, that rate of change would be 1 cent per year. Because it went up 2 cents over 2 years, that's like going up 1 cent per year if we simplify that, right? From 06 to 08, let me make this a little smaller so I can see everything. We go from 39 to 42 cents, so 42 minus 39 divided by 8 minus 6. 3 divided by 2. I know it's okay to use a decimal. 1.5 cents per year. Our last change from 2008 to 2013, it changed from 42 to 46 cents. In other words, a change of 46 minus 42 divided by 13 minus 8. That is 4 divided by 5, or 8/10 of a cent per year on average. That's the rate of change across the 5 years. In other words, it took 5 years, but it did go up 4 cents. On average, the rate of change would be 8/10 of a cent per year. Okay. That's our rate of change. That's kind of some stuff we're looking at here. If I'm trying to plot the points, we had, let's see here. Oh, I already forgot the points. Let's see, here's what we had. All right, in 2003, it was 37 cents. So 3.37. 4 was also 37. 6 was 39. 8 was 42. And 13 was 46. It says connect the points with line segments to make a statistical line graph. Okay, we got this going on in here. Got that going on here. It says label the vertical increase, the rise, and the horizontal. We've already kind of done this, right? Between years 4 and year 6, went 2 cents up over 2 years, on an increase of 1 cent per year. From 2006 to 2008, it went up 3 cents over the course of 2 years, which is an average of 1.5 cents per year. And in the last, between 8 and 13, it rose 4 cents over the course of 5 years, making it 8/10 of a cent per year, just like we talked about in the beginning. Where is the greatest rate of change? Notice that our greatest rate of change value is 1.5 cents per year between 2006 and 2008. Between 2006 and 2008. That is our biggest value once we've taken and simplified that, right? Notice how it's not H. 4 and 5 are bigger numbers, but 4 divided by 5 is smaller than 3 divided by 2. Keep that in mind. I've seen it happen. All right. Also, let's look at the slope. I know it's not a perfect one, but this right here, The slope between 4 and 6 is a little bit less than the slope between 6 and 8. We're going to talk about that one in a second too. Let's talk about determining slope of a line. I'm going to completely ignore this page. Completely ignore this page and go right to determining the slope using the slope formula. And as we go ahead and do this, I'm going to point out 4 things. Well, one thing 4 times. I could have 4 different types of slope. I could have, and when I'm talking about lines of rate of change in this case, I could have, maybe it looks like that. I could have another line that looks like that. I could have a horizontal line. I could do that. And I could also have a vertical line. So let's put some arrows on the end of these, Mr. Raymond, to be correct. In this first example, notice how it's going uphill from left to right. This is an example of a positive slope. I'm going to kind of make this one right here. It's a positive slope going uphill from left to right. So when I do my slope formula, I should get a positive number if I'm picking 2 points from this line. In the same way, the next example is a negative slope. If you see it going downhill between 2 points, you'd have a negative slope. Again, negative slope is downhill from left to right. And think about it, right? As I'm going down, I go down and then right. My rise is negative, my run is still positive. The next example, there's no rise. Remember, because slope is rise over run? There's no rise. It's 0 divided by some number, and 0 on top of a ratio divided by a positive number or a negative number is going to be 0. This is going to be a 0 slope, a horizontal 0 slope. In the next way, a vertical line would have only rise divided by 0. There's no run. When you, again, this was 0 divided by a number. And this case is a number divided by 0. If the 0 is in the denominator, if you're dividing by 0, that's what we call undefined. This is an undefined situation. This is an undefined slope. This is undefined because we cannot define the slope because it's being divided by 0. The slope formula. I know you've seen this and that's good. Like, this is super key important when we do this. The slope formula. If I have 2 points on the line, if my coordinate point x1, y1, my coordinate point x2, y2, pick any 2 points on the line that aren't the same point. Pick any 2 points. My slope, we use that variable m. M is slope, that will be important. Y equals mx plus b, some stuff like that. M equals y2 minus y1 divided by x2 minus x1. It could, if you like, it's okay to have y1 minus y2 as long as you have x1 minus x2. That's okay as well. You just cannot have like the 2 minus 1 divided by 1 minus 2. That just can't happen. That just can't happen, right? Keep them consistent. If you want the x, if the ones first, that's fine. Keep them both 1 and x and y. If you want the 1 second, do the same thing. So in this slope formula, let's go ahead and look at this example right here. All right. Now that I'm looking at this, I'm going to take and ignore all this business right now. I'm going to ignore all this. We're going to do our own thing. It's the right thing. It's the same thing, but we're going to do it on our own. I've got 2 points that are defined on this line, right? I'm going to get my slope formula going, right? M equals y2 minus y1 divided by x2 minus x1. If I do that, remember what we're trying to do is find the slope of the line and describe the slope as positive, uphill left to right, negative, downhill left to right, 0, horizontal, or undefined, vertical. Y2 minus y1 divided by x2 minus x1. Let's get our coordinate pairs. It doesn't matter which one you pick, just be consistent. If I said this is x1, y1, and this was x2, y2, all we got to do is plug these values in. y2 would be 3 minus y1, which would be -1, divided by x2, which we called 2, minus x1, which we called -2, right? We just did this point and this point. And if we simplify that, I know it's getting kind of weird over here. 3 minus a negative is positive. I know you're excited to say that, and you even said it if you're at home. You might even say it if you're in here watching it. Plus a positive. 3 plus a +1 is 4, divided by 2 minus a negative is plus a positive. Great job. 2 plus a +2 is also 4. That simplifies to 1. Our slope is a +1, which, kind of, I'll just do this, highlight there, a +1. It goes uphill from left to right. We've already seen that, so we know it should have been positive. If it wasn't positive, we made a calculation error, but we found that our slope goes uphill. It's a positive number. 4 divided by 4 is 1, and that's our slope. The slope is positive. The line rises from left to right. Well, Mr. Brayman, what if you don't have a graph? If you don't have a graph, well, that's okay. We've got a table of values for this function. We've got this table, 3, 2, 3, 4, 3, 6, 3, 8. It doesn't matter which one you pick to be x1, y1, and x2, y2. I'm going to make this right here my first point, x1, y1. And just for fun, I'm going to pick this one as x2, y2. If you want to pick something different and check it, I bet we get the same thing, because that's how slope works. Let's go ahead and do this thing. All right, I'm going to completely ignore what they're asking me to do because I can do that. And I'm going to ignore this guy right here. And I'm going to focus over here. y2 minus y1, or 8 minus 2, that's a really bad 8. 8 minus 2 divided by x2, 3 minus x1, also 3. And let's go ahead and simplify. I've got 8 minus 2 is 6. 3 minus 3 is, 0. Dividing by 0, what did we call that just a second ago? Let's go back and look. If I'm dividing by 0, a number divided by 0, that's an undefined slope. Oh, that's interesting. Is this a vertical line? I think it is. This is an undefined slope, or UND. The slope is undefined and the line is vertical. If you're not sure, here's something kind of cool you can do. Why don't you just make up your own graph? Watch this. Boom, graph. It doesn't have to be perfect, right? X is 3, Y is 2. 3, 2. Then I've got 3, 4. Oh, I can see it already. 3, 6, 3, 8. Yeah, this line is definitely vertical. And that's the best part. It's the beauty of this, right? We found that and our math backed it up, and then we kind of sketched it. We didn't have to do a perfect sketch either, and it works. Math is beautiful. Love me some math. Here's where we're at. Guess what time it is? Guess what time it is? Well, right now it's about 5:40 p.m. wherever on a Saturday. But I don't know what you're doing. I mean, that's just what time it is here. Your turn. Go ahead. You're going to do these. It's either going to pause for you if you're on Edpuzzle, or if you're on YouTube, hit that pause button, then come back in a second. Let's do this thing. Find the slope of each line passing through the given points, just like we've been doing. Describe the slope as positive, negative, 0, or undefined. We've got this graph over here. This is something I like about graphs. I know right away if this is positive, negative, 0, or undefined. This line is going downhill from left to right. Going down from left to right. I know right away that this is going to be a negative slope. I know right away that this is going to be a negative slope. And here's the thing. When I do my math, if it doesn't come out negative, I done screwed up. I'll have to figure out why. So let's take a look. I'm going to treat this as x1, y1, and this is x2, y2. And it doesn't matter if I switch these around If I called this top one, if I called -1, 9, x2, y2, and 2, -5, x1, y1, it would come out the same way. Try it. Try it. It will come out the same way. My slope m is y2 minus y1 divided by x2 minus x1. Y2 over there, that looks like -5 minus y1, which is 9, divided by x2, which is 2, minus x2, which is 2, minus x1, which is -1. And from what I can tell, this is -14. 2 plus a +1, -14 divided by 3. Don't take it to a decimal, just leave it like that. Does this make sense? Is this a negative slope? Yeah, it sure is. It sure is -14 divided by 3. That's our slope. And it is negative. We reprove that once again. Let's go ahead and look at number 10. I'm going to pick, doesn't matter. I'm going to pick this one and this one. x1, y1, x2, y2. Why not? Why? M equals y2 minus y1 divided by x2 minus x1. If I've got y2, that's like 5 minus y1, which is 5. I see something interesting here already. I hope you do too. Divided by 3 minus 2. I end up with 0 divided by 1. Well, 0 divided by something that's not 0 is going to be 0. 0. My slope is a 0 slope. If I want to kind of plot this real quick, x is 1, y is 5, 2, 5, 3, 5, 4, 5. Look at that. Well, I just totally missed. That is absolutely a 0 slope, a horizontal line. All right. Now we're going to go on to part 2 here in a minute. Okay. This first part's all about just a calculation, the raw calculations. Part 2 is going to be all about how to interpret those calculations in a real world situation. So go ahead, stick around for part 2. We'll talk to you soon.